The Atlas, NASA's Maven probe, has gone silent. Or is it something to do with the deep space visitor, which is suspected to be operated by alien tech?
3i Atlas, update. What happens if scientists are wrong? All right, everyone. We have got another major update on 3i Atlas. The interstellar visitor is now just a few days away from its closest approach to Earth, and the scientific debate is heating up like never before. Today, we are doing something different. We are not speculating about aliens or pushing conspiracy theories. Instead, we are asking a question that every good scientist should ask. What happens if the mainstream explanation turns out to be incomplete or wrong? Let us find out. Before we go into the details, we need to establish something important. We are not here to promote conspiracy theories or claim that 3i Atlas is an alien spaceship. The scientific consensus is clear. This is a natural interstellar comet, and the evidence strongly supports that conclusion. Every major space agency on the planet agrees with this assessment. But here is the thing that separates science from dogma. Science is not about blindly accepting what authorities tell you. It is about questioning, testing, and being intellectually honest about uncertainties. The greatest scientific breakthroughs in history came from people who were willing to ask uncomfortable questions and challenge prevailing assumptions when the data warranted it. So today, we are going to do exactly that. We are going to examine the current scientific understanding, identify where the explanations have weaknesses or require unverifiable assumptions, and then explore what would actually change if scientists turned out to be incorrect about certain aspects of this object. Think of it as consequence analysis. Think of it as how science should actually work when we encounter something truly unprecedented. Why does this matter right now? Because December 19th is approaching fast. In just a few days, 3i Atlas will make its closest approach to Earth at about 1.8 astronomical units, roughly 270 million kilometers away. After that, it begins its long journey out of our solar system, accelerating toward the constellation Leo, and eventually back into interstellar space. It will never return. Whatever we learn about this object, we need to learn it in the next few months. And that means we need to be brutally honest about what we actually know versus what we are assuming. Let's lay out the baseline scientific position. According to NASA, the European Space Agency, and the overwhelming majority of planetary scientists worldwide,
right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
3i Atlas is the third confirmed interstellar object to visit our solar system. It follows Oumuamua, which passed through in 2017, and Borisov, which we observed in 2019. The object was discovered on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, operating from Hawaii. Since then, it has been under constant observation by virtually every major telescope on Earth and in orbit, including the James Webb Space Telescope, Hubble, the Very Large Telescope in Chile, and dozens of others. Here is what we know with high confidence. The object is traveling at approximately 64.6 kilometers per second. Its hyperbolic trajectory mathematically confirms it originated from outside our solar system, because no object gravitationally bound to our sun could achieve that velocity.
Small, natural, solid body that is a combination of rocky and icy material that evaporates as it warms when it's close to a star like the sun.
It passed its perihelion, its closest point to the sun, on October 30th at about 1.4 astronomical units. Right now, as of December 15th, it is approximately 270 million kilometers from Earth and continuing to brighten, currently at magnitude 12.5, which means you can see it with a decent telescope. The James Webb Space Telescope and the Very Large Telescope have detected typical cometary molecules in its coma, the fuzzy envelope of gas and dust surrounding the nucleus. These include carbon dioxide, water, carbon monoxide, cyanide, and nickel. The ratios are slightly different from solar system comets, but within the range of what we would expect from an object formed around a different star with different elemental abundances. The nucleus is estimated between 1.4 and 5.6 kilometers in diameter, based on Hubble observations from August 20th. It displays a coma, multiple tails, and active outgassing, all behaviors completely consistent with a comet being heated by the sun. The green color visible in recent images comes from diatomic carbon, a common molecule in cometary comas that fluoresces green when exposed to sunlight. Scientists believe 3I Atlas formed in another star system billions of years ago, likely in a region with different ice compositions than where our comets formed. At some point, gravitational interactions ejected it from its home system, and it has been drifting through interstellar space ever since, preserved in the deep freeze between stars, until our sun's gravity captured it for this brief visit. SETI researchers have searched for artificial signals from the object and found nothing. No unusual maneuvers have been detected. By every standard measure, this looks exactly like a natural object. NASA has called it an early Christmas gift for planetary science because it offers a rare opportunity to study material from another star system up close. And then,
there's a really exciting opportunity to study not only a different part of our galaxy.
Now here is where things get more nuanced. Despite the strong scientific consensus, there are aspects of 3I Atlas that have proven difficult to explain cleanly. We want to be absolutely clear about something. Difficult to explain does not mean impossible to explain. Every anomaly we are about to describe has a plausible natural explanation. But these are the areas where scientists have had to work harder to fit the observations into their models. First, let us talk about the persistent anti-tail. Unlike normal cometary tails that stream away from the sun due to solar wind and radiation pressure, 3I Atlas has displayed a stubborn feature pointing toward the sun. This has been observed consistently since July in both professional and amateur images. The mainstream explanation is that this is an optical effect caused by larger dust particles, around 100 microns in size, that lag behind the comet's motion due to their greater inertia. When viewed from Earth, these particles appear to point sunward, even though they are actually trailing behind. This phenomenon has been documented in other comets like C/2014 UN 271 and has been understood in cometary science for 50 years. But here is the weakness. While the optical explanation works for many observations, some researchers have noted that the anti-tail's persistence and behavior do not perfectly match all the predicted models. It remained visible through perihelion and continues to be observed even now, which is unusual, though not unprecedented. The explanation requires specific particle size distributions and viewing geometries that cannot be directly verified. Second, consider the unusual composition. The comet shows a remarkably high carbon dioxide to water ratio, about 8:1, which is significantly elevated compared to most solar system comets we have studied. There are also depleted carbon chain molecules like C2 and C3, and elevated nickel content without corresponding iron in typical ratios. The mainstream explanation attributes all of this to its extrasolar origin. The object likely formed in a region of its home system where different ices dominated, possibly farther from its star, or in a system with different overall chemistry. The weakness here is subtle, but important. We are essentially saying we cannot explain the chemistry with local comet models, so the chemistry must reflect unknown conditions in an unknown star system we cannot visit. This is scientifically reasonable, but it is also somewhat unfalsifiable. Any unusual observation can be attributed to its mysterious extrasolar origins without the ability to confirm or deny. Third, there is the trajectory alignment question. Harvard astrophysicist Avi Loeb has pointed out that 3I Atlas entered our solar system in a way that seems statistically improbable for a truly random interstellar object. Its path is closely aligned with the ecliptic plane, the flat disk where the planets orbit. Some calculations suggest only a 0.2% chance of this happening by random chance. The object also made relatively close passes to multiple planets and follows a trajectory that overlaps with the direction of the famous 1977 WOW signal detected by SETI researchers. The mainstream response is that these are post hoc statistics, calculations made after the fact that can make almost anything seem unlikely. Once you observe where something came from, you can always calculate improbable coincidences. Critics like astronomers Jason Wright and Steve Desch argue that for objects that happen to be traveling near the ecliptic, which many will by pure chance, these alignments become much less surprising. Fourth, there is the puzzle of early activity. 3i Atlas began showing visible cometary activity at over 6 astronomical units from the Sun, farther out than expected for typical water ice to sublimate. The standard explanation points to hypervolatiles like carbon dioxide and carbon monoxide, which can sublimate at much lower temperatures and greater solar distances. This is perfectly plausible, but the rapid onset of activity and the lack of expected outbursts or fragmentation still require refined models that account for the object's ancient, radiation-hardened surface, acquired during billions of years in interstellar space. Fifth, there is the non-gravitational acceleration. Like Oumuamua before it, 3i Atlas shows acceleration that cannot be fully explained by gravity alone. For 3i Atlas, this is confidently attributed to outgassing, basically jet propulsion from vaporizing ices pushing the object slightly off its expected gravitational path. The models generally work, but there are uncertainties in the mass loss calculations, and some observations showed apparent thrust continuing even when visible tails were minimal or absent. We want to emphasize something critical here. Every single one of these anomalies has a reasonable natural explanation supported by cometary science. The anti-tail is understood optical physics. The composition reflects extrasolar origins. The trajectory statistics are likely misapplied. The early activity comes from hypervolatiles. The acceleration comes from outgassing. These explanations are not weak because they are wrong. They are weak because they require assumptions and conditions we cannot directly verify or observe. Now we arrive at the heart of our discussion. Let us be very specific about what being wrong would mean in practice and what would actually change as a result. We are going to walk through several scenarios ranging from minor corrections to paradigm-shattering discoveries. Scenario 1. Scientists are wrong about the composition models. If the unusual nickel-to-iron ratios or the extreme carbon dioxide dominance truly cannot be explained by any natural extrasolar formation model, we would need to significantly revise our understanding of how interstellar objects form and evolve over billions of years. This would not necessarily mean artificial origin. It might mean our theoretical models of protoplanetary chemistry in other star systems are fundamentally incomplete. The change would appear in astrophysics textbooks and planetary science courses, not in history books about first contact. Scenario 2. Scientists are wrong about the anti-tail physics. If the persistent sunward feature cannot be explained as an optical effect from large dust particles, we would need to develop new models for how cometary material behaves under different conditions. This could reveal new physics about dust particle dynamics, sublimation patterns, or electromagnetic interactions in cometary environments. This would be an exciting scientific advancement and a revision to standard cometary models, but still firmly within natural explanations. Scenario 3. Scientists are wrong about the non-gravitational acceleration. If outgassing cannot fully account for the object's trajectory changes and no other natural mechanism emerges to explain it, this would be the scenario that raises the most serious questions. It was exactly this type of unexplained acceleration that made Oumuamua so deeply controversial.
Well, moments after capturing a close-range look at an interstellar intruder, the 3i Atlas, NASA's Maven probe, has gone silent.
If 3i Atlas shows similar unexplained thrust that persists despite increasingly sophisticated models, it would reinforce a troubling pattern across multiple interstellar objects and demand either revolutionary new physics or serious consideration of alternative hypotheses. Scenario 4. The most dramatic possibility. Scientists are wrong about the fundamental nature of the object itself. If multiple anomalies compound together, if the composition, trajectory, acceleration, and behavior collectively cannot be explained by any natural model, we enter unprecedented territory. This would potentially mean seriously considering technological origins, whether active spacecraft or ancient debris from another civilization. So what would actually change if Scenario 4 came to pass? First, we would need to completely re-evaluate Oumuamua and Borisov. If 3I Atlas showed clear signs of artificial origin, we would have to ask whether those previous interstellar visitors were also misidentified natural objects. Oumuamua, in particular, had its own troubling anomalies, including its unusual shape, its lack of cometary activity, and its unexplained acceleration that scientists still debate. Second, SETI would undergo a fundamental transformation in its approach. The search for extraterrestrial intelligence has focused primarily on radio signals and optical communications for decades. Finding a physical artifact would completely shift the paradigm toward looking for objects, technosignatures, and physical evidence rather than just signals. Every future detection system would need to be redesigned with this possibility in mind. Third, every interstellar object detected in the future would be scrutinized under entirely new protocols. The Vera Rubin Observatory is expected to detect roughly 1 interstellar visitor per year once it becomes fully operational. Each detection would become a potential first contact scenario, requiring immediate international scientific coordination and careful analysis before any public announcements. Fourth, and most profoundly, there would be enormous philosophical and societal implications that are difficult to fully anticipate. Confirmation of extraterrestrial technology, even ancient defunct technology, would rank among the most significant discoveries in human history. It would force every religion, every philosophy, every assumption about humanity's place in the universe to be reconsidered and potentially revised. But let me be absolutely crystal clear about something. None of this is currently warranted by the evidence. The data we have right now fits natural explanations. What we are describing are consequences, not predictions. The purpose of this thought exercise is to understand what is at stake, not to claim that scientists are actually wrong about anything. So why bring you this update right now? Because we are in a critical observation window that will never come again. In 4 days, on December 19th, 3I Atlas makes its closest approach to Earth. After that, it continues accelerating away from us, traveling toward the outer solar system, and eventually toward the constellation Leo, heading back into the vast emptiness of interstellar space forever. Here is what is happening right now with observations. The comet is glowing greener and brighter than ever before, likely due to increased diatomic carbon emissions in its expanding coma. Recent images from Gemini North and other major observatories show spectacular views of its multiple tails and dynamic jets streaming from the nucleus. The XRI-SM X-ray telescope detected a massive 400,000-kilometer halo around the object in late November, confirming charge exchange interactions between the solar wind and cometary gases exactly as predicted by natural models. More data is on the way. The James Webb Space Telescope is expected to provide extremely detailed spectra in early 2026 that could definitively answer many remaining questions about its precise composition and any remaining chemical mysteries. The ExoMars and MAVEN spacecraft observations have already improved trajectory tracking accuracy by a factor of 10 through triangulation measurements between Earth and Mars. Amateur astronomers worldwide are capturing nightly images as the object brightens in the pre-dawn sky, adding to the collective data pool. The scientific community remains highly confident in the natural comet explanation. Every new observation so far has been consistent with that interpretation. The green glow comes from standard carbon compounds. The X-ray halo comes from expected solar wind interaction. The jets come from sublimating ices heated by the sun. Nothing observed has broken the model or required exotic explanations. But that is exactly why we need to keep watching with open minds. Science works by making predictions and then testing them against observations. If 3I Atlas does something unexpected in the coming weeks or months, something that truly cannot be explained by standard cometary physics, we need to be intellectually prepared to update our understanding. That is not conspiracy thinking or wishful thinking. That is simply the scientific method operating as it should. Avi Loeb, the Harvard astrophysicist who has been most vocal about maintaining openness to the artificial hypothesis, has suggested that something unexpected might happen as the comet approaches Jupiter's orbital distance around 2027. He speculates about potential activation or trajectory maneuvers that would reveal technological origins. Most mainstream scientists dismiss this as baseless speculation without supporting evidence, and we tend to agree that prediction is not grounded in current data. But we will certainly be watching regardless of what we expect to see. The next few months represent a crucial and irreplaceable opportunity.
Are watching because 3I Atlas is about to make its closest.
As 3I Atlas recedes from both the Sun and Earth, it will gradually fade from visibility. By spring 2026, only the largest professional telescopes will be able to track it. Shortly after that, it becomes just a memory, a rich dataset to be analyzed and debated for years and perhaps decades to come. So here is where we land after all of this analysis. 3I Atlas is almost certainly a natural interstellar comet, exactly what scientists say it is. The evidence supports this conclusion. The models work and continue to work. The global expert community agrees. There is no cover-up here, and no mystery waiting to be solved by amateur investigators on the internet. We'll continue bringing you updates as new observations come in and new analysis gets published. Make sure you are subscribed so you do not miss the December 19th closest approach coverage. And if you want to see this historic object for yourself, it is currently visible in the pre-dawn sky with a small telescope or decent binoculars. Look toward the east before sunrise for that fuzzy green spot moving slowly against the background stars. You will be looking at something that has traveled for billions of years across the galaxy to reach us. Thank you for watching. This has been your 3I Atlas update. Stay curious, stay appropriately skeptical, and keep looking up. We'll see you in the next one.